Welcome everyone, and thank you for joining our Donaldson webinar series. In this session, we'll be discussing choosing the right filter media for foundries. My name is Teresa Giselberti, and I'll be your moderator for this session. Currently, I'm the sales manager for our aftermarket sales team here at Donaldson. My passion and career has been in the industrial filtration market, specifically to the dust collection, troubleshooting, and operation for 23 years. Today's agenda: we will start out with the importance of dust collection in foundries, review basic dust collection designs and critical points, and we'll touch on some common issues in foundries. We'll go through factors in selecting the right medias, pleated bag solutions, and then we'll finish up with a Q&A session. Please submit all questions into the chat box as you think of them throughout the webinar, and we'll answer them towards the end. This session will be recorded, and we'll be posting this webinar series on our website. For those of you not familiar with Donaldson Company, we've been solving customers' complex filtration challenges for over 100 years. We were founded in 1915 by Frank Donaldson Sr., who invented the world's first filter for a tractor engine. Donaldson today services customers globally in 40+ countries, whether it's our industrial solutions, mobile solutions, or life sciences division. In the industrial solutions division, we service many markets and are driven to provide the best technical expertise and product portfolio. Our sole purpose at Donaldson is advancing filtration for a cleaner world. Before I introduce our featured speaker, I want to explain a little bit how to engage with us. As stated earlier, this will be recorded and everyone will be muted during the session. But as you think of a question throughout this webinar, please type them into the chat box, and Lee will be able to answer those toward the end of the sessions at our Q&A. If you have to jump off early, don't worry, we'll reach out to you and make sure your questions are answered. During the webinar, Lee may ask you a question or two. You can either chat, or he may be able to respond with a thumbs up or thumbs down, and you can access by clicking a face icon at the bottom of the screen. And with that, I'm pleased to introduce our featured speaker, Lee Wald. Lee has 25 years of technical troubleshooting experience, and I've had the pleasure of working with him 20 of those years. Currently, he's the pleated bag technical manager for Donaldson. He has spoken twice at the AFS Advanced Air Seminar, where he shares insights and knowledge in air filtration systems. The floor is all yours, Lee.
All right, thanks, Teresa. I really appreciate that. And more importantly, I really appreciate all of you joining us today. I know time is precious. Everybody's understaffed. And so I really appreciate you taking a little bit of time out of your day to hopefully learn a thing or two. And so speaking of that, just to go ahead and get us started here, if you wouldn't mind using the features that Teresa just explained, let us know what your interest level or experience level is with your dust collection systems. Type in A if you're brand new to them. If you're kind of mid, type in B. Or if you're real experienced and just looking for a little bit something else, type in C. And so once we get all that stuff, we'll kind of go on here. But just again, thank you so much for joining us today. As Teresa said, we've worked together for about 25 years. And I really do appreciate dust collection systems, and hopefully all of you do as well. I know my family's real sick of me talking about dust collectors all the time, and so it's real nice to finally sit in an echo chamber where we can all truly enjoy the glory that is the dust collection system. We've got the time scheduled today, and I'm definitely very respectful of your time, and so I will try not to bloviate too much and go on like a grandmother about her first newborn grandchild. And so I will just get through all this, and please feel free to ask any questions if it's specific or general, and we'll try to get them all addressed the best we can. So with that, what is the importance of dust collection? There's a lot of different dust collectors out there, a lot of different industries, and every one of them is truly unique. The most important part of a dust collection system is to improve the air quality. That's why they were first, dust collectors were first invented, over 100 years ago, and they were used during the Industrial Revolution to just help keep the workers safe, help them send them home at the end of the day safe and being able to breathe. Of course, today, most people are worried about their air permitting and passing the EPA standards. So there's environmental concerns. In the plant, I've kind of touched on safety concerns and hazards. And most importantly, anymore today, I think one of the biggest things, or one of the most important reasons to really keep your dust collectors up and running is employee retention. Everybody I talk to, they have open spots, and they always have open spots. And it's really expensive to bring in a new employee and try to get them trained up and get them to the point where they're very beneficial to the company and helping the company move forward. And so employee retention is also just such an important reason that you need to clean up your air environment and keep everybody happy and safe. So what is foundry dust? It's primarily foundry dust is going to be sand and silica. There's going to be metal oxides, some organic materials used in the binding, and a lot of these are real dangerous if inhaled, and they can really lead to a lot of respiratory problems. So I think one of the biggest focuses on today is just keeping the workers safe. And of course, ineffective dust collection can also lead to some product issues in the end. And so that's kind of in general what foundry dust is. And I'm sure you're all very, very well aware of it because you kind of live in it every day. And so with that, there's a lot of different applications for dust collectors across the foundry. It kind of starts off with sand and silica transfer, moving all the sand around, getting it to your sand molding position or stations, getting the molds made, pouring in the molds, getting the sand reclaimed, shot blast, all of that stuff. You're all very well aware of that. So you have dust collectors all over the plant. And so let's go ahead and talk about some system basics on dust collection systems. We're going to kind of go into a little bit of troubleshooting, some pick out some better medias, better filter styles as well. But so when you're putting in a system and designing it, there's a lot of things to consider when you're designing your system. And as I stated earlier, every dust collector is unique. And so, some of the design factors you're going to look at, what are you collecting? How often is your dust collector running? Are you running 24/7, or do you shut down every day and go through dew point? Is the dust explosive? Are you gonna leave room for future expansion? All that stuff. And so there's a lot of different things to consider. And so I'm going to kind of, each one of these you could bloviate about for hours on end. And so I will try to kind of just touch on a few of them and try to give you a few tips. There's a lot of different styles of dust collectors out there, but the two styles that I'm going to focus on today probably make up 95% or more of the collectors that you have on your site. The first style is the cartridge system dust collector, and the cartridge collectors are really great, and they're primarily used in the shot blast and finishing areas. They can move a very large volume of air with a real low footprint. And so we'll touch base on those a little bit and talk about some of the systems that they're best for, and then also talk about maybe some improvements that can be made or better filtration medias. And then the other type of collector is the baghouse or pulse jet dust collector. And the pulse jet dust collector it cleans during operation, and so that was the main reason it was invented. I think back in the 60s or 50s maybe, is because before they used just shaker style dust collectors where they would have to shut off the operation and shake the dust off the filters. Well, the pulse jet dust collector cleans during operation, and you can make them a lot smaller and more compact, and so they take up a lower footprint. And so I would guess to say 80% or more of the dust collectors that you have in your facility are pulse jet dust collectors. And so we'll be talking about these quite a bit today. They typically use a fabric bag in the cage, or also they can use pleated filters as well. And so we're going to kind of go over the whole dust collection system. We're going to talk a little bit about hood designs and inlet duct work on how to optimize that. We're going to talk a little bit about hoppers, and then also we're really going to look at the inside of the dust collector and talk about ways to maximize that performance. There are a few key terms that I want to go over just to make sure that we're all operating on the same level. And so the four things that I want to jump into that are all very, very important. And if you call me with an issue, these are the things that I'm going to ask you. The first is the actual cubic feet of air, the ACFM. And that's just simply the amount of air that you're putting through your collector. We're going to touch on the AMR, or air to media ratio. Some people call it air to cloth ratio. We're also going to look a little bit at velocities and differential pressures. So first off, ACFM, actual cubic feet of gas per minute. This is a volume measurement, okay? And so it's going to be measured in cubic feet per minute. And it's just quite simply the amount of air that you have going into your dust collector. And we'll get into why this is important. Most people don't have a full grasp of what their ACFM is at any given time. Systems are designed for a certain ACFM, and the fan curves, you might have access to the fan curves. And so the actual amount of air can fluctuate based on total static pressure of the system. And so we'll kind of talk about ways to make sure that you're able to move it. But the best way to measure the ACFM is to simply use a pitot tube to insert it into the ductwork to see what your actual airflow is. Air to media ratio, when you have your airflow, the next thing that I'm going to want to find out is how much cloth area you have in your baghouse. And so the reason I need to know that is when you have the filter media that you have inside your dust collector, how much of it is going to determine how easily you can pass that air through it. So a real good example that an old manager of mine used to tell me is like, it's the stadium theory, right? So if you have a stadium full of people watching a football game, at the end of the football game, how fast can they get out of that stadium? Well, that depends, right? It depends on the number of doors. So think of the people in the stadium as your airflow and the number of doors as your cloth area. So the more cloth area you have, the easier you're going to be able to get those people out of the stadium. And then, of course, to just sit in their car in the parking lot and not move for another hour. But that's a whole nother issue. And so AMR is the amount of cloth area versus your actual airflow. And how you factor that is you just figure out the amount of cloth that you have in your dust collector and then take your ACFM and divide by that. So how do you figure out how much cloth area you have? That's a great question. Let me explain. So the amount of cloth area with a bag and cage is real simple. It's you find out what the diameter of the filter is, take it times pi, times the length of the filter, and that's going to give you, and all of those measurements should be in inches. And so if you have a 4.625 by 10 foot bag, you're going to want to take 4.625 times 3.14. And then sometimes people will say times 10 because that's the number of feet the bag is, but you want to make sure you're taking it times 120. And then what you want to do there, so then you have square inches. So you take that number and divide it by 144, and that's going to give you square feet of cloth per filter. And then you just take that times the number of filters. Now you know how much cloth you have in your baghouse. So take the ACFM, divide it by the amount of cloth you have in your baghouse in square feet, and that's going to give you your air to media ratio. And so on a pulse jet dust collector, you're going to want to keep that number at about a 6-to-1 or lower. If you have pleated bags in your dust collector, you're going to want to keep that number at about 3.5 or lower. And with cartridges, I'm going to say about 2.5 or 2 and lower. And so depending on the type of dust collector, the recommended AMR is going to change some, but it's important to make sure that you're within the norm, because if that AMR gets too high, you're going to have a lot of troubles. And if you're trying to figure out the total filtration area of a pleated bag, it's real simple. You just take you count the number of pleats in the bags, and then or the number of pleats in the pleated bag, and then you take that times 2, and then you measure the pleat depth, and you take it times the pleat depth, and then you take it times the pleat pack overall length, right? So real easy. Or just call your Donaldson rep and they'll tell you. That's much easier. So next I want to talk a little bit about velocities. And so there's 3 different velocities that we need to be concerned about. The first velocity is the inlet velocity, and that is the speed of the air moving through the ductwork. And so I kind of talked about that a little bit. I mentioned a pitot tube and how you can insert a pitot tube into the ductwork to measure your airflow. And what that pitot tube does is it actually is measuring the velocity of the air moving through it. And then the pitot tube, most of the time, they're going to be automatic. So you just punch in what the diameter of the ductwork is, and then voila, you have the ACFM. And so the inlet velocity is a real important number, though, because you have to have it just right. It's like that bowl of porridge in the Bears, right? Can't be too hot, can't be too cold. It's got to be just right. The second velocity I'm going to be talking about today is can velocity. And the can velocity is the speed of the air. So the inlet velocity, okay, it's all entered into the bottom of the dust collector. And now, where's the air going to go? Well, it's going to go up, right? And so the speed of the air, once it enters the dust collector, moving up until it hits the bottom of the filters, that's called can velocity. And so we'll get into that a little bit on why that's important. And then finally, the third measurement that we'll be talking about today is interstitial velocity. And so the air is coming to the dust collector, it's moved up, it's hit the bottom of the filter bags, and now it's going up in between the filters, okay? And that speed, it's going to be measured in feet per minute. And that speed is very, very important because if it gets too high, you're going to have some troubles. And so we'll talk about that a little bit as well. And so what's the importance of all these numbers? Well, if the inlet velocity is too low, you're going to have a bunch of material building up in your ductwork. And if material builds up in your ductwork, it's going to, you could have collapsing ductwork, which is a safety issue, and, et cetera, et cetera. Too low of airflow could lead to unplanned outages to clean out the ductwork. And too low of airflow, most importantly, you're probably not going to be picking up the dust that the dust collector is intended to pick up, and you're going to be having a lot of dust in your process, in the air, and it's going to cause a lot of housekeeping issues. Now, if you have too much airflow, you have the potential where wherever your hood is, whatever dust it's trying to suck up, maybe it's going to be sucking too much at that pickup point. It's actually going to be picking up good product. Sand reclaim is a really good example of this. If your velocities and your airflow is too high, you might be beating the heck out of your ductwork and your filter bags and causing premature failure of those and getting holes in your ductwork, and it all could lead to a lot of increased costs. The final thing I wanted to talk about here with this part is differential pressure drop. Want to make sure that everybody knows what the differential pressure is. It's just the difference in the air pressure between the clean air plenum, after the air has gone through the filters, and the dirty air plenum where the bags are hanging. So the difference in that pressure is called the differential pressure, and it's typically measured in water gauge or inches of water. And the reason this is so important, because it's like I always call it the stethoscope, the doctor's stethoscope, right? He grabs it, throws it on your chest, a couple deep breaths, you get lightheaded, etc. And then, but it really helps to tell real simply what's going on inside the dust collector. And so that's going to be one of the very first things I always ask, what's your differential pressure drop? Because it's just that important. And so with that, let's go ahead and start talking about some of the real common issues that I have in the foundry, or that I see in the foundry industry. The most common I see is abrasion. You guys are dealing with a lot of very, very abrasive dusts with the sand and the shop blast and the grinding dust. That's all going to be very, very abrasive, and that's going to lead to a lot of issues. The second most common thing that I see is emissions, and this can come typically off the furnace and sand reclaim. And emissions are just simply really fine dust that makes it through the filter bags and it goes out into the environment. And of course, nobody wants that because once it's outside, now you're dealing with neighbors, the EPA, the car lot next door that has to repaint their cars every 6 months and sends you the bill, etc. And then one final thing we'll talk about is blinding. And blinding is just defined as the filters just simply aren't allowing air to get through anymore. And when that happens, your differential pressures are going to shoot sky high, and you're not going to be getting any airflow through the dust collector, so you're not picking up any dust where you're supposed to be. So let's dig into some of the things that I see with these issues. So the first one is abrasion. The two most common failures that I see from abrasion are going to be by far the most common is holes in your filter bags. Okay. And then the second one that I'll see is actually holes in your ductwork. And that can typically be mitigated by reworking your ductwork a little bit. But the holes in the bags are a little bit harder to address because they are what they are. So let's talk about a few different ways that we can look at that. So one of the most common issues that I see with holes in the bottoms of the filter bags, actually comes from the baffle plate. Okay, a lot of dust collectors, when they are first made, the inlet duct is going to come in at the bottom of the dust collector, and it's just going to have a strike plate. And the purpose of that strike plate is just going to be to push the air down into the hopper. Well, the theory is that you're pushing all the dust into the hopper, and then, the rotary airlock is going to kick in and it's going to carry all that dust away and everything's great, right? But what happens so often when you have just a strike plate pushing the air down into the hopper is that airflow is actually going to pick up a lot of that dust that you've already cleaned off the filter bags, and it's going to re-entrain it into the gas stream, and it's going to start beating the heck out of the filter bags on the opposite side of the inlet. This is a real common issue that I see, and there's one main thing that you can do to fix it. You can shorten the filters to get them up out of the gas stream, but then you have to look at what your AMRs are, right? Because you can't push your AMR too high, and if you shorten your filters, what are you doing? You're taking doors out of the stadium, so it's going to be harder to get that air through. And then some people put what are called tough skirts on the filter bags, and to just basically reinforce the bottoms of them. But that's just kind of kicking the can a little bit. Then the final way, and I'll dig into this one a little bit more, is to switch to pleated bags. But another way, that you could address it is to just fix the baffling, right? Instead of just having that strike plate push the air directly down into the hopper and push it up the wall, let's go ahead and put in a ladder vane baffling system, where the baffles are, instead of just having one pushing the air down, you have a series of strike plates going across the whole dust collector. And that's going to help to evenly, first off, it's going to help to knock the dust out. And then it's going to help to evenly distribute the air up into the dust collector. And this is definitely going to take care of the problem that I mentioned above. And then it's also going to really help distribute the air evenly and the dust evenly, so your filters are going to be able to share the burden and last a lot longer. Another way to solve abrasion is to help minimize the amount of dust that your dust collector sees. And so I see a lot of issues on conveying belts where they capture the dust, but they're not capturing it, but they're capturing more than dust. They're actually capturing most of the end product. And so on the left, you'll see a design that I typically see where they will just enclose the conveyor belt and then just stick a straight duct right into it. Well, what happens is that capture velocity of that duct, because it's right above the product, is going to be really high. And you're actually going to be sucking a lot more than just the nuisance dust. You're going to be sucking up a lot of sand. And then all that sand is going to end up just beating the heck out of your bags and ductwork along the way. So the middle and the right hand picture are just a couple ideas for you. maybe you want to elongate that capture area a little bit to help the dust settle down onto the conveying belt. But more importantly, you're going to want to get that straight pipe out of there. And you're going to want to allow a little bit of a drop zone where all the heavy dust or where all the heavy sand is actually going to stay on the conveying belt where it's supposed to be, and it's not going to get sucked in. And so just a real simple, change in your pickup points can make a lot of difference in the dust collector. And then also ductwork. I'm not going to go through this one, each or one by one, but just, avoid 90-degree turns, avoid, bringing in, ductwork at a bad angle. And a lot of this stuff happens when you put a new grinder on and you're just like, just run it over and stick it in that ductwork. And what can happen with a lot of these bad ductwork designs is you're gonna wear out the total, or you're gonna wear out those corners on the ductwork, and then you're also gonna add a lot of static pressure to the system. And I haven't really talked about that, but static pressure is just the total system pressure, and your fan can only pull so much air. And so if you have a 90-degree turn in there instead of a recommended curve turn, it's going to add static pressure to the overall system, and your fan's not going to be able to pull as much air. You're not going to get as much dust pickup, et cetera, et cetera. So really working at the ductwork design is going to help, or really, making sure you're properly designing your ductwork is going to make a lot of difference with abrasion and just overall system performance. And so emissions, I touched on that a little bit. We kind of already talked about what are primary causes of emissions. Holes in filters, lots of times that's from abrasion. Filters not installed correctly. I'm not going to really dig into that one because there are so many types of filters. We'd spend too much time on it, but it's very important to make sure that you're properly installing your filters. I've seen a lot of funny stories over the years. But I also want to talk about two more things that we haven't touched on, and I want to talk about picking the right media and cleaning your filters. And so when it comes to media selection, you have a lot of different processes, right? And you have a lot of different dusts. And so you really gotta make sure that you're applying the right dust or the right filter to the right dust. How big is your dust? Is it really abrasive? How much does it weigh? Is it does it pick up moisture along the way? And so you really have to know what you're picking up before you throw in a filter bag. And so once you really know everything you need to know about the dust and the gas stream, and then you can just go ahead and take a look at this easy to read chart, right? And, we're talking about all the different medias available, P84, polypropylene, polyester, it's all out there, right? Or another really easy way to make sure that you're picking the right media is to go to shopdonaldson.com or donaldson.com, and we have a media selection guide, and it's actually a pretty cool little flow chart, and that's shown in the upper right hand corner. But let me zoom in on this a little bit. It's really easy. So once you know everything about your gas stream, just jump in here. Is it over 275? Yes or no? If it's no, does it have static? No. Is there moisture present, etc. Right? It's a real easy way to go through and make sure that you have the right media, and it'll help you. Or just call your local Donaldson rep, and they'll absolutely help you out as well. And we'll share a link to the media guide, just so you can save that to your favorites and pop it in there anytime you want. But then another really important thing to consider when you're picking your media is how that media actually filters the dust. And something that a lot of people think when they put in a standard polyester felt filter, they're thinking that the filter is, it's in the name, right? It filters the dust. Well, it actually doesn't. Standard felt and woven fabrics actually need a dust cake to be efficient. The fabrics themselves are not good the filters themselves aren't really good filters. So you have to have an established dust cake on the filter in order for that filter to be truly efficient. And so in order to make sure that you're being efficient, You have to have the dust cake on there, which leads into cleaning, and it's a pretty hard thing to measure. Another option you have is surface filtration, and that is newer medias that are available that actually capture the dust on the surface of the filter. And there are four types of surface filtration. There's spun-bond polyester, EPTFE membranes, nanofiber technologies, and then a Duralife fabric. So I'm going to jump into each one of those real quickly, just so you can know the differences there. And then I'll talk a little bit more about how to make sure you're cleaning properly if you do have a filter that uses surface filtration. I'm sorry, depth filtration. The first one is spun-bond polyester. So the way filters are made, a standard polyester felt, it's a needled felt, and so it's just, thousands, millions, however many. I've never taken one apart and counted the number of fibers, but it's just a lot of fibers, trust me. It's a lot of fibers that are needled together to form a thick felt, and that's then installed on the dust collector, and all the dust is collected on it. The spun-bond polyester is actually a continuous filament, and so the way the spun-bond polyester media is made, it's very dense, but yet still permeable. And so it actually filters 99.99 down to 0.5 micron. And so it's extremely efficient. On its own, it's MERV 10 to 12 rated. And it's very, very efficient. And it's a great way to make sure that you're capturing all your dust. You can put other finishes on it, and I'll go into that a little bit to make it even more efficient. The second of the four types is Tetratex, is Donaldson's brand name for it. Expanded polytetrafluoroethylene. That's fun. What is expanded polytetrafluoroethylene membrane? Go back, might get in trouble, use a couple words that maybe I shouldn't use. Polytetrafluoroethylene was first invented by DuPont. They called it Teflon. And what do you get when you take this polytetrafluoroethylene and stretch it and laminate it to a material? You get a really, really fine filtration media. It's 99.99% efficient, and it also has a slick surface like the Teflon pan. The first company that did that put it on boots, gloves, clothes. It's called Gore. And but this, many companies have been using this technology since. And so the same type of concept that's maybe on a lot of your hunting coats and boots, where the water sheds off of it and no dust is able to get on it, that's used in filtration media as well. And the benefits of the EPTFE membranes, all the dust is going to slide off of it, especially if you have any moisture in there in your ductwork, and it's going to be extremely efficient, and it's going to last a lot longer because the dust isn't being allowed to penetrate into the media. Now, in the foundry industry, I'd be kind of careful with using EPTFE membrane. Make sure you're talking to your rep about the actual process, because the Achilles heel of membrane is oil. And so if you are using it like off of your furnaces or off of your molded departments where you might have some binders or some oils coming from like some dirty steel that you're melting, you could run into some issues using an EPTFE membrane. So again, make sure you know your dust, talk to your rep, make sure it's the right application. But and also, if it's very abrasive, you wouldn't want to use an EPTFE membrane because it would abrade it off. But in the right application, it's a fantastic product. And then also UltraWeb. UltraWeb is Donaldson's patented brand name. And what UltraWeb is it's a nanofiber that's laminated over the top of conventional medias. And I didn't mention this about membrane. Membrane actually goes on any substrate, so you can put it on polyester, aramid, etc. Nanofiber is the same way. You can put it on spun-bond polyester, on cellulose, and whatever substrate it goes on, it's going to make that much more efficient. Okay, if you put it on spun-bond polyester, it takes the MERV rating from 10 to 12 up to 15. And then here you can see the MERV ratings for some of the cartridges that you'll see the different cartridge styles. And so typically the limiting factor for ultra web is just going to be the substrate it's on. So whatever the temperature and chemical capabilities are of the base fabric of the ultra web, that's going to be its limiting factors. And the benefits, of course, extremely fine filtration and lower pressure drops, so your filters are going to last a lot longer. And then the final filter, or the final type of filter I wanted to talk about, is Duralife. Duralife is like the spunbond polyester. It's made a little bit different. This is made up of hundreds, thousands, whatever fibers, kind of like a standard polyester felt, but it's actually hydro entangled, and so it gives it a real smooth, dense surface. And it is lighter weight than your standard polyester felt bag. The standard polyester is 16 ounces. The Duralife is 10.5. And so it gives you a really dense surface that's going to be a lot more efficient than what your standard polyester felt bag is. But here, a couple red flag areas in the foundry industries. I'd be careful if it's in a real abrasive environment. If you have filter bags that are getting a lot of holes in them, Duralife might not be the answer because it is a lighter weight fabric. But if you don't have any of the any abrasion issues, it can really help out with the capture of fine dust to help with your emissions. And then kind of wanted to go back real quick and talk about the depth filtration. Okay, a lot of people are going to stick with polyester bags because they're cheap. All these other things that I've talked about, the spunbond, the EPTFE membrane, they're going to be more expensive than your standard polyester felt bags. And sometimes the budget is the budget, right? Well, if you're going to use the standard polyester felt bags, the thing that I'm going to recommend the most is to make darn sure that you're cleaning those filters right. Now, if you over clean polyester felt bags, remember, the polyester felt has to have a dust cake on it to be efficient. So if you're over cleaning the filter bags, you're going to be allowing fine dust to penetrate into the interstices of the fabric. That's a fun word. Into the voids of the fabric. And it's either going to blind that fabric off or it's going to end up as emissions. And so by cleaning on demand, to only clean when your differential pressure is, over 3.5 and before 6, you're going to limit the amount of cleaning that you do on your dust collector, which is going to save you a lot of compressed air. But then you're also going to make your dust collector run a lot more efficiently. And most importantly, you're going to get extended filter life, because beating up those bags with a pulsing system is one of the causes of eventual failure. So if you can limit the amount of pulses, you're really going to be doing yourself a whole lot of good. But if you are going to use a clean on demand system, make sure that the tubes going to your photohelic gauge are clean. Because if that tube, especially the one coming out of the dirty air plenum, the tube, of course, that measures the differential pressure, if that tube coming out of the dirty air plenum is plugged, you're not going to be cleaning properly. You might run into some systems. So make sure you have a maintenance schedule in play to make sure that tube is cleaned. So with that, I want to talk for a few minutes about pleated bags. Pleated bags, I touched on them a little bit earlier, and I want to spend a little bit of time on them because I really, really had a lot of success with these in the foundry industry. A pleated bag takes the place of a bag and cage. And so it's in a pulse jet dust collector. You throw your cages out, you put the pleated bags in there. Why would you do that? Well, let me tell you. So when you switch to a pleated bag, the most important thing that you're getting is cloth area, right? Remember the stadium? More doors, you're adding more doors. Now, with this, you do want to run these at a lower AMR. Remember earlier I mentioned 3.5, but because of the pleats, you're typically going to get 2 to 4, 3 to 5 times the amount of cloth area in that dust collector, and that's going to be it's going to help lower your differential pressure, and it's going to really help that dust collector run a lot better. And so with the lower and with the more cloth area, my apologies, you're going to get a lot longer filter life typically as well. But one of the main reasons that I see success in your industry is abrasion. Remember, abrasion is an issue on those filter bags. And even if you have proper baffling in, like this dust collector does, you're still going to be beating the heck out of the bottoms of those filters. If you put in pleated bags, remember a lot more cloth area, and the longest filter we make in the pleated bag is 80 inches. And so if you currently have 10-foot bags that are getting holes in them, go ahead and switch over to the pleated bags, and you're going to go from 120 inches to 80 inches, or maybe even less if your AMR will allow it. And you're going to lift those filters up out of that gas stream, and you're going to let that dust settle out before it ever reaches the filter. Plus, the bottom of the filters are typically made of a hard polyurethane puck, and so it's not going to. So even the dust that does smash into the bottoms of those filters isn't going to wear it away like it does on a felt filter. Efficiency is another fantastic reason to switch over to them. Remember, I mentioned earlier, MERV 10 to 12. The spun bond polyester is far more efficient than what your standard polyester felt is, and I apologize. And so remember, it uses the surface filtration versus depth, and so just as it is, it's going to be more efficient. So even if you don't have your cleaning in check, you're still going to be getting extremely efficient operations. And then finally, one of the things I wanted to talk about with them is reducing the number of filters you have. So because you're greatly increasing the amount of cloth area, you can sometimes remove some filters from the dust collector. And so what are the benefits of that? Well, say you had an abrasion issue on the opposite side of the inlet because of the strike plate. So instead of going in and switching out all your baffling, why don't you just close off the last 5 rows where you're seeing the problem? Another thing that you can really help out is the interstitial velocity. And remember, that's the speed that the air is moving up in between the filters. If that's too high, when you pulse your bags, the dust isn't going to fall off because the speed coming up in between the filters is going too fast, so it just sticks the dust back onto the bags. And this can lead to real high differential pressures and loss in airflow. So if the AMR allows it, you can go ahead and close off every row, every third row, whatever the situation might be. Remember, every system's unique. And you can close off some of those rows, slow down that interstitial velocity, and really help that dust fall out and keep it off of the bags. And like any fabric, the pleated bags come in a lot of different options, varying on the temperature and the gas stream. But typically, the most common used in your industry is going to be a simple spun bond polyester, and or sometimes we can put an oleophobic finish on it, or we might even put some ultra web on it as well. And so with that, I was given 45 minutes and I took 44. Thank you. I'll give a minute back. And so with that, I want to go ahead and say thank you again. I really hope that today was helpful. Any one of these subjects I could have dove into for an hour or two, but of course, we're all limited on the time. So I hope you're able to pick up a thing or two. And, with this, I'll open it up to questions. And also just please feel free to reach out and with any questions that you might have for me after this webinar as well. I'd love to help. So Teresa, do we have any questions come in during my bloviating?
We do have questions coming in, but I want to give a little bit of time to people. If you guys want to start asking more questions on the chat, please do so. Thanks, Lee, for everything. Great job on that. Just a heads up, everybody who's attended, you will receive an email with a link to the recording from today's session. Also, there has been some links that were been added throughout here through the chat that Lee were talking about, media selection guides, and et cetera, other things that are added. So go in there and save those links if you want. If you don't get to it, reach out to us. Our contact information is on the screen. Also, we're going to put another link out there for a survey. So it's a satisfaction post-survey webinar. And if you could take the time to fill that out, it would be much appreciated. So we want to go right into our first question. Is static pressure same as restriction?
I would say yes. You know, every fan is going to be, or every system is going to have a static pressure on it, and static pressure just simply is resistance. You know, how much work or how hard is that fan going to have to work to overcome, you know, the bend, the filter bags. You know, typically a dust collector accounts for, you know, 4 to 7 inches of static pressure across the system. So yeah, I would say, sorry, I'm kind of going off there a little bit, but yeah, static pressure is just the total resistance of the whole system and what that fan needs to overcome.
Okay. The next question is, do we have services and changeouts for baghouses in Seattle, Washington?
Yes. And I guess contact your local rep, or just reach out to Teresa and I, and we'll get you set up. We do have service crews across the country to change out filter bags.
Any other thoughts, Lee, that you want to give?
Oh, not really. Sorry if I talk too fast. But you know, I think the most important thing here is to to just know that every system is different, and to really, you know, when a dust collector is experiencing problems, the first thing everybody wants to blame is the filter bags. But lots of times there's so many other things going into it, and you know, my favorite thing is hey, give me a call with your absolute worst collector in your foundry, and let's see if we can't make it work better. You know, there's typically something that can be done for every problem. You just got to really, you know, get another set of eyes on it, and you know, try to find the right solution, the cost effective solution, etc. And so, you know, call us up with your worst collector, and let's see if we can't keep you out of it a little bit. Because keeping you out of the dust collector is my number one goal.